we are starting probability. Okay, before starting this chapter, we should be very familiar with the terminology of this chapter, with what symbols I'm going to represent what things. This is terminology of probability. Probability is the mathematical study of uncertainty, how uncertain an event to happen. Okay, so it's a study of uncertainty, as you already know. The value of see, an event is likely to happen. It can happen, like definitely will happen. So it will be 100% certainty. If the event is completely unlikely to happen, then the probability will be 0%. So in percentage, probability only lies from 0 to 100, right?
Yeah.
Okay, but probability is not the percentage thing. You can show the probability in percentage, but probability is a number lies from 0 to 1. Your probability value will always lie between 0 and 1. Okay, in mathematics at least. It will tell us how likely an event is to occur. In core definitions, we will need some experiments, like whatever event will happen, we call it experiments. A repeatable procedure with a set of possible results, like experiment can be rolling a dice, tossing a coin. Okay, experiment can be you attending a class, you are having a meal twice a day. These are the experiment. It can be anything. You will get good marks or you will get bad marks. So this is all experiments. After experiments, we got outcomes. So while tossing a coin, if tossing a coin is my experiment, is my event, experimental events are same. Tossing a coin is my event or experiment, then the outcomes can be either it will be head or it will be tails. Okay, the two sides of the coin are heads. If you toss it, either you will get head or you will get tails. Okay, but once in an infinite times, it can be that you roll a coin and then coin just stays like this. It either goes head or tail, but it's once in an infinite times. It's very unlikely to happen. So only two outcomes are there. Okay, flat outcomes, head or tails. If it's not flat or vertical, it's a different thing. It's very impossible. You don't even count it. Okay. After outcomes comes a sample space. See, experiment is happening in your mind. You can see the experiment happening over the desk. But if you want to show the experiment mathematically, it will be shown in the sample space. Sample space contains all possible outcomes of the experiment. This is your sample space represented by small s. You will write like this in curly brackets. Curly brackets you will write whatever possibilities are there, head or tails, like this. This is sample space, either head comes or tails comes. That's it. Okay, what is head? Head is outcome, tail is also outcome. What is happening? Tossing a coin is experiment. For example, for rolling a dice, sample space can be collection of all the outcomes. Outcomes while rolling a dice can be 1, 2, 3, 4, 5, 6. Only these outcomes are possible. So sample space is the collection of all possible outcomes that can happen in your experiment, represented in curly brackets separated by commas. Sample space is represented by capital S. Okay. Experiment was something theoretical, right? Tossing a coin, rolling a dice, a theory, a statement in alphabets. Event. What is an event? So event will be represented by small e. And what is an event? Event can be a specific subset of outcomes from a sample space. This was a sample space, but not all possible things can be your event. For example, your event was getting a even number on rolling a dice. So even number are only 3. So your event value will only be 2, 4, 6. That's it, right? Okay. So probability is defined for the events. PE. If I want to say what is the probability of the event, then you will write only PE, not the whole statement. PE. What is the formula of PE? Number of favorable outcomes. Number of favorable outcomes that you already want, the desired outcomes over total outcomes. See, these are the 6 total outcomes, but favorable were only 3. So number of total outcomes. Whatever entries are written in the sample space, that comes in the denominator by number of total outcomes. Whatever entries are desired in the event 2, 4, 6, they are the favorable outcomes. That becomes our probability. Okay.
Yeah.
Now the probability value can be 0. If probability value is 0, what does it mean? It means the event will not happen. Okay. Impossible event. When probability is 0, it shows impossible events. It will never happen. For example, on rolling a dice, if I ask you what is the probability of getting a 7, so
Sure.
when you will check in the sample space the number of favorable outcomes, 7, you want to count 7, but there is no 7, so you will write 0 here. 0 upon something is 0, so the probability will be 0. When probability is 0, it means impossible event, the event cannot be possible. When probability of an event is 0.5, which means 50%. 0.5 means 50%. Then even chance. Okay, it can happen, it cannot happen. 50-50 chances. When probability of an event is 1, that shows 100% certainty. The event will definitely happen. So it's certain event. It will happen. For example, on rolling a dice, if I say the event is getting a number, a positive number. You are getting positive number. All 6 entries are positive. Numbers from 1 to 6 on the dice are positive. So either way, in all the dice rolling events, you will get a positive number always. You will never get a negative number. That is a certain event, where your favorable outcomes are equal to your total outcomes. That is the certain events. 100% probability represented by 1. Okay. Then we need the complementary events. Complementary. For example, you are having a bet with me on tossing a coin. I say there comes a head. You are saying there comes a tails. I'm saying there comes a head. Probability of getting a head. So what is the number of favorable outcomes? So example space is what? On tossing a coin, there is only 2 events. Either comes head or comes tails. Okay. In doing so, probability of getting a head. So number of favorable outcome, which is head, is only 1. How many total outcomes are there? 2. So probability becomes 1 upon 2, 0.5.
Yeah.
Okay. Now, if I am asking you, okay, tell me what is my probability of getting a tails on tossing a coin. You don't want to calculate it. What you can do is probability of getting a tails. Doesn't it mean probability of not getting a head?
Yeah.
It means the same, not getting a head. So I have represented by not getting a head. So dash I have written here. Which this particular thing, PH dash, becomes the complementary of this event, PH. And the formula of getting the PH dash complementary of the first event, you just have to subtract 1 minus the first one, PH. That's it. You know the value of PH 0.5. So 1 minus 0.5 again gives you 0.5. And hence, without solving it again, you have calculated the probability of getting a tails. Now you can ask me, sir, I can find the probability of getting a tails by the usual method. Why I'm using complementary methods? So it is useful. Okay, not right now. You can do it manually also using this particular formula. But when the question will be complicated, the complementary thing will be useful there. We just have to subtract the probability of the first event from the to get the complementary event. because getting a tails means not getting a head, and probability of not getting a head is 1 minus probability of getting a head. That's it. In the same way, if my probability of being present in the class, let's say it's 1, it's definitely highly present in the class. I'm asking what is the probability of me not present in the class. You just have to simply subtract it from 1, you get 0. So 0 is my probability. It is very impossible that I will not be present in the class. I will be present in the class. Okay. This was the complementary probability. So if you want to make a rule of it, complementary probability is represented by P E dash. If PE is your event, you already know the value of PE. You already know the number. Then PE dash becomes 1 minus PE. That's it. For example, if the probability of getting rain tomorrow is 0.3, the probability of getting a rain, so P rain is given to be 0.3. I'm asking you what is the probability of not getting a rain? P not rain. How will you find this? You only see these are the complementary events. P not rain is the complementary to P rain. P rain is the complementary to P not rain. How will you identify that complementary? So if it rains, the opposite is not raining. It's completely the opposite thing. So that becomes 1 minus P rain. See, PE dash becomes 1 minus PE. So P not rain becomes P minus 1 minus P rain. 1 minus 0.3. 1 minus 0.3 gives you 0.7. So the probability of getting no rain is 0.7. 70% chances are such that rain will not occur. 30% chances are there that rain will be there. Okay. One more thing. You can obviously see from this particular formula also, this example also, that the sum of all probability, the sum of all probability is 1 always. You want to check it out? Yes. See, P rain plus
Yeah.
P not rain will give you what? 0.3 plus 0.7 is 1. Always. In all the examples we have done earlier also, you will check it out and you get 1. Probability of getting, okay, the sum of probability of all the probabilities is 1. It's certain. Mathematically we show it like this. Sigma. We call it sigma. The sign is known as sigma. Sigma PE of sigma sample space. That means probability of all the events. Sample space contains all the outcomes. Is always 1. What is sigma? Sigma simply tells you have to add all the values. Sigma is for addition. Sigma represent you have to add things. I know it's a symbol. You may find it difficult or confusing right now, but only think about it as sigma. Sigma represent addition. So when I'm writing sigma, it's just telling you that sum of all probabilities. Rather writing the spelling sum of all probabilities, I'm writing sigma. Sigma stands for sum. Sum of all probabilities. PS means sum of all probabilities. Sigma means sum of all probabilities. We got this. Okay. When I will show you the real examples in further chapters, then you will see what is the use case of sigma. Okay. Let's think about the combined events. Combined events. Okay, now what are these? Combined events, also known as the addition rule. Addition rule. In questions, identify this particular rule. Identify that you have to use the addition rule by identifying this particular spelling. Or if you ever seen the question written there or, okay, you may find or in multiple places, but if the question is about or and, so when it is about or not and, then we'll use the addition. What is it? So we are dealing with the multiple events. We will look at how they interact using this set theory terminology. For example, firstly, in this thing, we are having the mutually exclusive events. Exclusive itself means they do not depend over each other. They are different events. For example, I'll have good food today and it will be rain. They are two different events. These events are exclusive. So raining has nothing to do with my good food, or good food has nothing to do with the rain. If I say my mom will only cook good food when it rains, then they are inclusive. They are dependent over each other. That my mom will only cook good food when it rains. Otherwise, bad. Mutually exclusive events. Okay, I'm writing food events. For example, rolling a 2 and rolling a odd number on a single die. They are independent. So what is the experiment or event? Is rolling a 2 and rolling a odd number. They are different. Why they are different? Because 2 is not an odd number. They are not dependent over each other. Neither odd number is 2. So for that, we will use the addition rule for the mutually exclusive event. If the event is telling you find the probability of getting a 2 and getting an odd number on rolling a dice. On a single die. So they are not dependent. So we'll use the addition rule. Addition rule is for the mutually exclusive events. So what is the question? The question is you either get a 2 or, see, I told you, you can identify this thing by multiple ways. If you capture or you capture mutually exclusive events by your feeling. If you ask yourself, get rolling a 2 or getting an odd number, yeah, they're not independent. They're not dependent. They're independent. They're not related to each other. That means it should be mutually exclusive, and for mutually exclusive, we use the addition rule. I haven't tell you what is the addition rule yet. I'll tell you. So probability of getting this 2 or getting an odd number will simply be probability of getting a 2 plus probability getting an odd number. That's it. You have to add these probabilities differently, like you're solving a question differently. If the question was only about getting 2 on a dice, it becomes there is only 1 2. So sample space says the outcomes are 1 2 3 4 and 5 and 6. So rolling a 2, solve this question differently. They are exclusive. You can solve them differently and separately. So getting 2 is only once. So 1 upon out of total outcomes, which is 6, 1 upon 6, plus probability of getting an odd number. How many odd numbers are there? 3, 1 and 5. So in counting 1 2 3, there are 3 odd numbers over total outcomes, which is 6. Probability becomes what? 4 upon 6. That is 2 upon 3. Okay, so if you were not aware about the addition, if I haven't told you that you can do it, it is allowed when a single event. Okay, the question is like rolling a 2 or getting a odd number. So they are exclusive events. We can simply add them. Or you can capture or written in the question. If you capture or between two events, it is a question of mutually exclusive events. You have to use the addition rule, solve the probability. It can be more than 2 also. It can be 5 or 6 events also. Getting a 2, getting an odd number, getting a negative number. Though there is no negative number on the dice. Okay, they can say getting a prime number. There can be 3 or 4 events also. But as long as there is or by your feeling, you can check all the given events, all 3 or 4 events are mutually exclusive. They are not dependent over each other. Then you are allowed to use the addition rule. Okay. Simply add the probabilities of all the events like this. Probability becomes 2 upon 3. Okay. That means if probability of a event like getting 2 or getting a odd number p, a or p, it becomes probability of getting 2 plus probability of getting odd number. That's it. This becomes your formula of addition. Okay. What if the events are not mutually exclusive? They are somehow overlapping. Somehow getting an odd number and getting a 2 overlaps. So it's not in this particular example. We'll form a new example. Okay.
Was this one called the subtraction thing?
Yeah, this was the mutually exclusive events. This one. if mutually exclusive events are there, the one I'm saying is mutually inclusive events. Right now, for mutually exclusive, this is stands true. Mutually inclusive, or you can also say non-exclusive events. Inclusive means non-exclusive. Mutually inclusive. The question can be, an example, different example this time. Okay, on the dice example, it was for exclusive events. For inclusive, I have discovered an example. Drawing a single card from a standard 52 cards deck. Okay, from the playing cards, which are 52 in number. So total cards we are having is 52. From the 52 cards, you have to draw a single card. Okay, I'll draw it. But what is the probability of getting a king or a heart? A king or a heart? We are still stuck on the or thing, right? A king or a heart. So if you know about the playing cards, so there are 52 cards. Out of 52 cards, the 13 cards, there are 4 packs of 13 cards. In total, you are having 52 cards. Out of 52, you are having 4 packs. 13, 13, 13, and 13. 13 of 52 are of spade, black in color, hearts, red in color, club,
30 each.
and then what do you call it, the other one?
Spade.
Spade is done. Spade, heart, club. Spade, heart, club is done.
Diamond.
Diamond. Okay, heart is diamond only. The black one is left. We got spade. That we call as hukum. Cards, playing cards. Yeah, so we are having hearts, diamonds, you're right, diamonds, clubs, and spades. Okay, so heart and diamond are red. Heart and diamonds are red. And then your club and spade are black. Your spade is like a leaf. This is our spade. And the club is like another leaf which has 3 faces like this. This is club. Okay. While solving question, it is quite important that we understand. Only then we will be able to see. The question will be formed from 3 events mainly: coins, dice, and the difficult one is the playing cards. 52 cards are there. 4 packs of 13 cards each. Spade, black. Club is also black. Red is heart, so it is in the heart shape. And then diamond. Diamond is in the diamond shape again. Like this. These are the cards we are having in total. Okay. Among the spades also you are having what? 2 aces. Okay. So aces of ace. Each card has 1 ace. Okay. Each card has one ace. So in total you are having 2 aces black and 2 aces red. Right? Same thing goes for kings also. 2 kings black, 2 queens black, 2 jays black. Call it jack. And the red card are also same. 2 red kings, 2 red queens, and 2 red jacks. How many are there? So in the 13 out of 4 cards are the face cards. Okay, ace is not considered a face card. Ace is ace only. We call it ace, and all 3 They are known as face cards. Question, we have to understand the terminology of this. Okay, so the king, queen, and jack are the face cards. Ace is not counted in the face cards. Number cards. So how many are left? 13 out of 4 are ace or face cards. 9 are left, I think. Right? So they are from where to where? They are from 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. From 2 to 10, there are the number cards. So in total, if you count from 8 to 10, there are total 13 cards of each pack. So now comes to the question. The question was about getting a king or a heart. Alright. So are they exclusive events? No, because getting a king is a different thing. But getting a heart, okay, this one, it contains a king of itself. So these events are somehow related because getting a heart also means getting a king. Getting a king also means getting a card of hearts, which is king itself. They are inclusive events. How you will solve these kinds of questions? That is the question. Okay, so addition rule will be different this time, which says, okay, what is the probability? Let's solve it like differently. What is the probability of getting a king? So among all cards of 52 cards, how many kings are there? If we are solving the first probability this time, how many kings? 4. So 4 over 52 will give you what? Let's give it 52 only. It will help us better. Okay. What is the probability of getting a heart? So heart cards are only 13. 13 over 52. We got this. Okay. Now, what card? Now I'm saying a king. What is the probability of king and a heart? A card which is king and heart at the same time. How many cards are such? Which is heart, which is king also, which is heart also. Only one card.
Oh, okay.
Yes. So one card out of the 52 cards. Okay. So the probability of getting king or hearts will be PK plus P heart and then minus PK and P hearts. So if I show you, that will become, that was the question, getting a king or a heart. And this becomes, what is the probability of getting a king? 4 upon 52. Getting a heart, 13 upon 52. Minus both king and heart, 1 upon 52. While solving this, we'll get the probability of getting a king or a heart. The probability becomes, so 13 plus 4 is 17 minus 1, 16. 16 over 52. That is our probability. You can leave it here, you can simplify it also. When you will simplify, you will get 4 upon 30. That is our answer. So that from this question, we can just make sure one thing, that if they are asking us a probability of OR, then it becomes, okay.
I don't know.
So if one of the event is A, one of the event is B, and both are inclusive events, they are related. So earlier when they were exclusive, so PA or B simply became what? PA plus B, PP. But when they are exclusive, okay, when they were exclusive earlier, this was the formula. But now they are inclusive, related. Formula changes. For inclusive, formula of PA over B or B becomes PA separately plus PB separately minus PA and B. Because A was king, B was the heart, which was only one. This becomes a formula of the inclusive events. Right?
Yeah.
Okay, remember it this way. Now we're talking about the combined events, which will be solved by the addition rule. Combined events will be identified by seeing and. I already told you, in certain question there will be or there will be and. Or question, you have to add. If events are exclusive, solve them separately, simply add them. The events are inclusive, solve them separately and also subtract TA and P. Like this. That's it. Clear, or I can say it again?
Yeah, I need to.
Okay, shall I say it again?
No, it's fine. I already wrote it down.
Okay. Now we are seeing the combined events. Combined events. What are combined events? So they will be solved by the multiplication rule. We will solve the event probability of first event, second event, and then multiply them. Multiplication rule will be identified by seeing a and in the question. Okay. Again, here also we got exclusive or inclusive events. I am calling it independent. Independent events means exclusive events. Let's see for independent events first. So two events are independent if the outcome of the first event does not affect the outcome of second event. That is independent event. For example, rolling a die and flipping a coin.
Yeah.
Or dependent events. Two events are dependent if the outcome of first event changes the probability of second event. For example, drawing a card from a pack without replacement. Okay. So when you will already, like, you have already taken out all the spade cards and then again you are taking out other spade cards, so the probability will be changing, keep on changing. The total number of cards are reducing without replacement. So they are dependent. But independent events are, now I'm seeing the independent events. Okay. The multiplication rule for independent events. If the events are independent, PA and PB. You'll understand from the example. You simply have to find the probability of A event and the probability of B events and simply multiply them. And you will get the probability of A and B. Here's the example for that. If there is probability of A event and B event and C event also, then simply multiply with the probability of C. Okay. For dependent event, it is a bit different. The events are different now, dependent. Okay, the events will depend on each other. So the way the mathematics of solving the probability of dependent events changes everything. Okay, they will be question specific. I'll show you with the example. No formula is there. This lecture is only dedicated for the theory. Okay. In the next one, I'll show you all the questions of all kinds. I'll solve with you, and then you will be getting the real feel of probability. Question is specific, dependent events. For example, I give you an example for dependent events. You have a 52 cards of deck. I'm saying, what is the probability of getting a king? And after that, in the second takeout, take a king again. What is the probability of that? So, getting a king in the first kind, getting a king in second takeout also, random. So, probability of getting a king first time and probability of getting a king second time. They are dependent events because when you will, what is the probability of getting a king first time? So when you will take the king first time, how many kings are there in total? 4 kings. So out of 4 out of 52 cards. 4 kings out of 52 cards. You have taken a king out. You are not replacing it again. You are not putting the king back into the deck. You are keeping it with yourself in your pocket. Now how many kings are left in the second time? 3, not 4, because the one is already in your pocket. You have not placed it again in the deck. How many total cards are there? Not 52, but 51. And this becomes a probability of getting a king on both the turns. So this event was dependent events. Numbers are changing this time. If I'm saying replacement is allowed, then you will take out a king. You'll see it's a king. Okay, you will put it again in the deck. So this time total cards becomes 4 again. And then 52 cards are in total because you're putting it back. But I have told you dependent events will be non-replacement ones. And the question it is written non-replacement. They will be dependent events. You only have to solve them in a question specific way. 3/51. If I say draw a king again in third time, and both the kings that you have drawn in first and second time are in your pocket, you have not replaced them. You have not placed them again. Replaced. Okay, you're not replacing them. So in the third time, how many kings are left? So 2 are already gone. Only 2 kings are left. How many total cards are there? So 2 cards are already drawn. 50 cards are there. If I say draw a king again in the fourth time, so it's K1, K2 and K3. So how many king is left? Only 1 king out of 50 or out of 49 cards this time. If I say draw a king in the fifth time again, then there is no king. 0. How many total cards are there? 48. And the whole probability becomes 0. Because when you multiply 0 with anything, the number is 0. So in the fifth time consecutively, your probability will be 0. This is how we solve the dependent events when there is AND using the multiplication. They will be question specific. Okay, there's no formula for that. When in the next lecture we'll see questions on that you'll understand it better. The question can be like, there is a bag. In the bag you are having 3 red balls, 2 blue balls. I'm saying what is the probability of getting a red ball in the first turn? In the second turn, what is the probability of getting a blue ball? This question is also, okay, I'm saying what is the probability of getting a red ball and a blue ball in second time? In first time a red ball and there is an AND I'm saying. So they are multiplication rule. AND stands for multiply. Okay. So probability of getting a red in the first time plus a blue in second time will be simply probability of red times probability of blue. What is the probability of red? So there are 3 red cards out of how many cards? Out of 5 cards in total. Okay. And then you have kept the red card in your pocket. You have not replaced it. The question it was mentioned, replacement is not allowed. Only then. How many total blue cards are there? Still 2. Total cards changes. How many total cards are there? Not 5, because one of the red is already gone. Total cards are now 2 red plus 2 blue. 4 cards. This is why I am saying these independent AND kinds of question, okay, dependent AND kinds of questions are question specific. There is no formula for that. Okay. What is conditional probability? Next thing. It's theoretical. If something finds you confusing, just leave it up. Okay. Let the things flow. Okay, we'll see questions, and these gaps, whatever gaps are created, they will be clear by the next lecture. Okay.
I'm not sure.
It's alright. That happens. Conditional probability. But I am sure that when you will see questions, these gaps will be filled. Conditional probability this time. Conditional probability measures the probability of an event, let's say B, occurring given that A event has already occurred. Okay. That means I'm asking you that my mom only cooks good food if it rains. So I'm giving you condition. If it rains, only then I'm gonna get a good food. There's a condition. Where there's a condition and they're asking you the probability of the first or second event due to the first event. The event has already happened. If it rains, then my mom will give me my food. They're conditional probability. Okay. This was theoretical. Mathematically, how do we solve the conditional probability? So conditional probability formula, for example, of B event. I'm asking you if B event will happen on the condition of A event. This is how we write it. If A event happens, only then B will happen. This way. This is how we write it. We draw a line between them. The first number is the second event. A event is the first event. If A happens, only then B happens. You have to find the probability of B condition of A. You read it like this. The line is read by B condition of A. Okay. So what is the formula of B condition of A? Is simply B probability of A event and B event over PA. This is the formula. B only happens when A happens. So A has to occur in advance. Okay, so which event is earlier? A has to be earlier. Comes in denominator here also. If you see, this is the division sign. P is the event which is conditioned on A. The formula equals P A and B over P A. For example, okay, a example of without replacement this time. Okay, a combined example for whatever we have seen. It says without replacement. You are not allowed to replace it. N kind of question. Dependent event. A bag contains 5 red marbles. 5 red marbles plus 3 blue marbles. How many are there in total? 8. Okay. You draw 2 marbles consecutively without replacement. Okay, we have to draw 2 marbles, one after another, without a break. What is the probability of drawing 2 red marbles? Probability of getting 2 red marbles without this replacement. So we can solve it simply. Probability of first red marble, PR1. So there are 5. In total we are having 8, 5 upon 8.
Yeah.
Now there comes a conditional probability. P second red marble on the condition if your first one is red marble. What if the first is not red? Then number changes. So I'm writing a condition here. Okay. If your first one was red, if first one is red, so again it says the formula becomes, if first one is red, you can simply solve it without using the formula also. If first is red, first the red is known without replacement. So how many red are in total? 4. How many marbles are in total? 4 plus 3, 7 this time, because one of them is already removed in your pocket.
Oh yeah. Okay.
7. So the conditional probability simply becomes 4 upon 7. You didn't even have to use the formula for that. Okay. Formula you already know. This one. Using formula also you can do it. But you can do it by your feel. Okay. Feel is better. So the combined probability of getting this and this. So getting in both chances getting the red one, the first is also red, second is also red. The probability is simply you have to multiply them. Right? Because the question was AND. In AND kind of question we multiplied, OR kind of question we add. 4 upon 7, and the final answer becomes 5 upon 14. Okay. This was all. Now we will go to the visualizing probability. It's a different thing. Firstly, we'll solve the questions on that. And before questions also, I'll just show you the visual information. It will help you to imagine probability better. No question will be skipped if you know the Venn diagrams.
Yeah.
Hardly take 2 minutes. Venn diagrams. In Venn diagrams also there are a lot of notation, a terminology of Venn diagrams. Before terminology, I'm just showing you. See, the information can be in a school. You are having 100 students in a school. Okay. Out of the 100 students, there are 48 girls, 52 boys. Okay. Also, there is some similarity between them. The students, okay, who belongs to, okay, there are some houses in this school, if you remember. There will be some categorization in your school also. Okay. In our school, there used to be 4 houses, like red, blue, green, and blue. So,
Yeah.
so if girls and boys belongs to red house, for example, so only there are 8 red house people, combiningly both red and blue. We don't know how many boys and how many girls. Okay. You have to show this information visually, and this is possible using the Venn diagram. Okay. Firstly, you will draw the school. I'm drawing school. Your school is the biggest thing that is given to you, biggest number that becomes a universal set. Because this is the universe of this visual information. There is nothing beyond 100, right? So we call it universal set. The 100 students are the universal set, are sitting in this whole square, or whatever this 4-side figure I have drawn. Okay, this is my U equals 100. All the students are sitting into this box. Now, girls. The green I am representing girls. These are my girls, and 48 girls are there. So I am drawing girls here. 48. Girls equals 48. See, circle comes inside your school. So out of 100, which were everywhere in the box, 48 are sitting in the green circle. Okay. 52 boys, they are different. Okay. No boy can be girl. They have to be drawn different. These circles cannot overlap. If they overlap, that means some of the guys are also girls, some of the girls are also guys, which is not possible. Okay. So these circles should not overlap. That's fine. So this becomes, boys becomes 52. Okay. So they were not overlapping this time, right? This was, we cannot show the 8 this thing, like the 8 red house people here. So this is how we represent. All the girls are represented in the green circle. This is my NG number of girls. Blue is my NB number of boys. Universal set is 100. If you want to show the sum of all boys and girls, so that is known as NA union B, NG union B. G stands for girls, B stands for B. Union stands for sum of all of them. A union contains everything, every possible entry. I'm calling it union. What is union? So, a number of girls and number of boys. Rather writing this, so we can write union. Union self represent. It's not you. It's union represented by this symbol. Okay, and they are how many? 100. You can just add them. The formula of union thus becomes NG plus NB. So G union B equals NG plus NB. This is also one formula. Okay. If I am asking you, red house people are how many? 8. So they are represented by this. How many girls and boys are collectively in the red house? This is known as intersection. See, this straight U is known as union. The inverted U is known as intersection. The common thing. Intersection means common thing. Union means total. Total also contains some union, the common thing. It already contains. Which is equal to. So how many girls and boys are in the red house? So it's 8. Okay. This is how we solve it. I'll show you the Venn diagrams in the next class more in detail. For now, just remember all of what we have seen till now. We have seen the probability formula first of all. Okay.
Mutually exclusive.
The mutually exclusive events, inclusive events, and sum of all probabilities will always be 1. Okay, no probability will be greater than 1. If you're getting your answer probability greater than 1, your answer is incorrect. If you're getting your answer less than 0, that is in negative, it is also incorrect. Your answer will always lie between 0 and 1. 0 represents an uncertain event, impossible event. 1 represents a certain event. Then we saw the combined events identified by or in the question. They will be solved by the addition rule. For mutually exclusive events, they are not dependent, so simply add them. For inclusive one, you have to subtract the T, K and H such thing. For the, if you find out and in the question, this is a question of combined events, again using the multiplication. You have to multiply the probability. For independent one, simply multiply the events. For dependent events or conditional events, you have to solve it question specifically. Okay. So the more question we will solve, more easier we will find it.
Yeah.
If we are meeting on next Tuesday, right?